So welcome to an introduction to Venn diagrams. I'm Professor Ward. I'm going to be talking you through this introduction. We're talking about different areas of the Venn diagrams, how to set it up for a basic two-set Venn diagram. So this is our generic drawing here. We've got our universe, which is represented by everything inside this rectangle here, and the letter U there to represent this is my universe. On it, I have two circles. Those are to represent my two sets or my two groups. I have this circle right here, which is all of set A, and then the circle over here, which is set B. Now, this is a great generic setup because it'll cover any of your cases. If, for instance, A is a subset or even a proper subset of B, well, then all the items that are in A are going to be here in this football shape because they'll be shared with B. Similarly, if B was a proper subset of A, all the items that are in B are going to be in here. If they are completely distinct groups, there's no overlap whatsoever, well, this area here in the shared would just be empty. There wouldn't be any items put in there. All the items in A would be here, all the items in B would be over here. In any case, any items that aren't members of A and B, but are part of my universe, are going to be outside the two circles, but still inside my universe. Typically over here, but they can be really anywhere out here that's outside of the circles. So we're going to start with our universe, and we're going to define our universe to be all items x, such that x is an element of the natural numbers, our counting numbers, 1, 2, 3, 4, 5, and x is less than 10. So these are going to be all the numbers that are going to belong inside my universe rectangle. Now, inside of that, and we're implying here that A and B are both subsets of U. A is all items x such that x is an odd number, 1, 3, 5. And B, well, I've just listed some items here. 1, 2, 3, 6, and 8 are elements of B. So if we have 1, 1 is an odd number, so it belongs in A, but it's also in B. So it's going to go in this little overlap area here. 2 is in B, but since it's not an odd number, it's not also in A. So it's going to go over here in this half-moon-shaped area that is only B. 3, again, is in both A and B, because it's an odd number, and it's on our list. Now, 4 isn't in either group. It's an even number, and it's not on B's list. So it's going to go out here in the universe. 5, it's an odd number, but it's not in B, so it's going to go in this half-moon-shaped area here that is only A. 6 is in B only. 7 is in A only. 8 is in B only. And 9 is in A only. Now, if we had some oddball, and this isn't typically the case, we usually are going to ignore this, but if we had an oddball like 31, it would belong here outside of the universe. Usually we don't list items like that, though. Now, if you were asked, what is A? In this case, I'm going to look at my diagram, and I have to get everything organized in the same way. I only really care what's in this A circle. I really don't care about B, how it interacts with A at all. So I'm just interested in the items that are in A. So that's these ones I've highlighted in red, 1, 3, 9, 7, and 5. Now again, typically you're going to list these in order, but there's not really any reason why you have to. If you're asked for A complement, here now we're doing an operation on our set A. So this is read A complement. Some people call this not A. So the first thing I'm going to do is I'm going to say, all right, well, what is A? And just like we did on the last slide, it's these 5 numbers, 1, 3, 9, 7, and 5. Now I'm going to apply the complement to that. And that just says, all right, well, not these items. So instead of having 1, 3, 9, 7, and 5, I'm going to take all the other ones, 2, 6, 8, and 4. These are not A. Similar to A, if I wanted B, I only care about B's circle. I'm going to ignore the overlap here with A. I'm going to ignore the stuff that's only in A, that's in the universe. I only want what is contained inside B's circle. So these 5 numbers, 1, 3, 2, 6, and 8. Now let's do some operations where they interact. So our first one is the intersection. And this is read A intersection B. This little upside down U looking thing is our intersection symbol. I like to think of the intersection of two streets where they cross. That pavement that's shared by both streets is my intersection. Similarly here, the items that are shared by A and B, that are both A and B, so these two numbers here are going to be my intersection, 1 and 3. The evil twin to the intersection is the union, or maybe the intersection's the evil twin, I don't know. The union, I write A union B with this U-shaped symbol being my union symbol. I like to think of union like a marriage. What belongs to A is now belongs to B, and the stuff they share they still have. It's going to be all of these items that are in A or B or both. So almost all the numbers, everyone except 4. Now we can do some more complicated things. So just like with order of operations with a regular math problem, you're going to do parentheses are going to block off portions of your statement. So here I have A intersection B, and that's in parentheses. Because it's in parentheses, I need to do this first. I need to figure out what A intersection B is. So I'm going to highlight that. That's this 1 and this 3. Intersection is the items that are shared by both. But now I'm going to apply the complement to that. So now this is saying, oh, well, all my items that are not this. So instead of 1 and 3, I'm going to get all the items that aren't 1 and 3. 9, 7, 5, 8, 6, 2, and 4. So this is my A intersection B complement. If I had A union B complement, again, I'm going to do inside the parentheses first. I'm going to figure out what that is. So that is these 8 items, 2, 6, 8, 3, 1, 9, 7, and 5. And now I'm going to apply the complement to that. Everything that's not in this list that's still part of my universe. So only 4.